Some investments pay interest more than once per year. In other words, compounding occurs more than once per year. How do we account for this when calculating the present value or the future value of an investment? Well, always remember that we need to be consistent with all inputs that we use. The most critical thing to look out for when using the future value or the present value equation is that the stated interest R, and the number of compounding periods, N, must be compatible, which means they have to be defined in the same time units. So if N is stated in months, R should be the 1-month unannualized interest rate. Suppose that a bank offers to pay 8% interest compounded monthly and you decide to invest $2 million for 1 year. Assuming that interest payments are reinvested at the same rate of 8%. What is future value of such an investment? Here, the annual interest rate is known as the stated annual interest or quoted interest rate, denoted by RS. In our example, the 8% is the stated annual interest rate. The number of compounding periods per year is denoted by M. In this example, it is 12 since we have monthly compounding. The periodic interest rate is just the stated annual interest rate divided by M, the number of compounding periods per year. So, in our example, that will be 8% divided by 12, which equals 0.0067 or 0.67%. So, if we want to calculate the future value, the formula to solve for FVN with compounding more frequent than annual becomes FVN is equal to PV multiplied by 1 plus the periodic rate, which is RS divided by M, to the power M times N, where N represents number of years. RS over M represents the periodic rate, and Mn represents the number of total compounding periods. Again, the periodic rate, RS over M, and the number of compounding periods Mn must be consistent. In this case, FV12 is $2 million times 1 plus 8 over 12 to the power 12, which is equal to $2,165,999. By comparison, if your 8% were based on annual not monthly compounding, you would have received 2 million times 1 plus 0.08 equals $2,160,000 at the end of the year. Note that the higher the compounding frequency, the higher the interest earned on prior period interest. Let us take another example. Assume, for example, that an investment of $5 million pays an annual interest rate of 12% that is compounded monthly over a period of 2 years. In this case, the interest on interest is accumulated on a monthly basis, rather than just at the end of the year. To solve this example, we will use the equation for FVN just mentioned, with PV of $5 million. N is 2 years. RS is 12%. M is 12 interest periods since we have 12 months in a year. And RS over M is 0.12 divided by 12, which is equal to 1%. And Mn is 12 times 2 equals 24. In this case, FV24 is $5 million times 1 plus 12 over 12 to the power 24, which is equal to $6,348,673. Find the full periodic compounding video on www.cognivisio.com.